start now. Welcome to the ProfessionalVMware.com vBrownbag's US edition. It's Wednesday, September 24th, 7:30 p.m. Central Time. Tonight's topic is VCDX Prep. Our guest is Jason Shiplett. Some quick notes. You can follow and join in on the discussion on Twitter by the various accounts, as well as using the hashtag vBrownbags. For all your vBrownbag needs, go to professionalvmware.com/brownbags. And we have our various shows starting at various times. Our APEC every Thursday night. Our EMEA is on Tuesdays, which, by the way, right now they're running the VCP NV Blueprint. Our Latin America is on Thursday, and of course this show on Wednesdays. By the way, our DevOps series will be starting next week. Again, our guest tonight is Jason Shiplett, and I'm your host, Ahmad Yunus. You can find me on Twitter at Ahmad_Yunus. And with that, I'm going to pass the ball on to Jason.
Hey, how's it going?
All right, should be.
All right, yeah. Okay, and you can see everything okay?
I can.
All right, so my name is Jason Shiplett. I'll be presenting this evening on VCDX Prep. So the things we're going to cover here, a little bit about me, then we'll go into a slight disclaimer. Then we'll move on to, where do you begin? How do you get rolling with the process? Into design components, additional documentation. So there are a couple of different things that you have to cover there. You have your architecture design document, and then you have some kind of ancillary documentation that follows on after it. Then I wanted to close up with the level of effort that I've put into this. I know not everybody has the same starting point, the same level of effort that they put into it, but this is going to be really just relating my experience and going through the whole thing and what it's been to me. And then we'll close out with resources that I've used, and we'll do some Q&A. So about me, my name is Jason Shiplett. I'm a senior consultant in VMware Professional Services. I work in the end-user computing practice. I currently hold VCP 3, 4, and 5, VCAP for DCD, DCA, and also just this year got the DTA and DTD as well. So that's the desktop administrator and desktop design, as well as the CCNA, which I've had for a couple of years. And we'll be defending for VCDX 5 data center virtualization in Palo Alto in just under 2 weeks. So, quick disclaimer, I'm a VMware employee, but this isn't a VMware presentation. There have been some presentations and the great set of videos that were done by John Rashid. This is just me relating my experience, and that leads us to number 2, and this tweet I saw the other day from vCloud Matt on Twitter. There's a lot of advice floating around about VCDX and different approaches that you should take. As with anything else, this isn't authoritative advice. Seek alternate sources of information. This is just me relating my experience and the process that I've gone through, as well as the research that I've done, the time that I've put into it, and trying to relate all those experiences back to you guys. So where to begin? There's some prerequisites that you have to cover. I think these should have been covered pretty well already, but just a refresher here. You have to have your current VCP, so at this point it's VCP 5 in whatever track you're going down, whether it's data center virtualization or desktop, cloud, or network virtualization. So just another quick caveat. So this is pretty much data center virtualization centric, although a lot of it will apply across the different tracks. So after you have your VCP, you can go on and take any VCAP exam. So you take the 2 VCAP exams for the track that you're going down. So if it's data center virtualization, you have data center administration, data center design. If it's desktop you're going down, it's desktop administration, desktop design, so on and so forth. The last track there is if you already have a VCDX, going for a different track-based VCDX. It's just submit your design, get your design accepted, and then you have the certification. You don't have to go through the panel defense more than once if you pass it. So some pointers there on getting started. Real design is always going to be easier to put together than a fictional design. So there were a couple of guys this last go-around who did defend successfully a wholly fictional design, but that's really those guys are fewer and more far between, just because the level of effort that goes into putting together a fictional design that is defensible, that you've thought of everything, that when you go through design with a customer, it's stuff that you just hit during the natural progression of the project, and being able to facilitate getting all of that information just out of the blue is difficult. And I actually had to do a little bit of that for my design to make sure that I hit all of the blueprint topics. And it is extremely difficult, and it adds a lot of time and effort into what you're doing. So real design is always better. Make sure you have a good handle on capacity planning. This is something that I ran into with my design, since it's one that I did a few years ago when I was still a customer. So I don't have hard and fast capacity planner data or VCOPS based data, or whatever you're using to do your capacity planning. If you can have that data on hand, whether it's a design that's already been completed, or if it's one that you're working on now, if you have that data, it makes going forward and doing sizing and stuff like that a whole lot easier. So next point there is understand the business. It's absolutely critical in this process to understand your business-oriented drivers for the project. So you have to know what the business is doing, what the workloads that they're using look like, and you need to know what they're trying to get to, so you can put together a design that fits those requirements. It's absolutely critical if you're going to move forward in this process to understand what the business is doing, where they're trying to get to, what the design that you're putting in place, what problems it's going to solve. Last point there is it's important to have a good starting point for your documentation. So if you're a VMware employee or a partner of VMware, we put out some templates that you can use, and that's actually how I started my documentation. I went through, filled it out as best I could based on the information that I still had, and contact with guys who still worked at the place I did the design. But in reading the blueprint and looking for what the blueprint is actually calling for, that documentation set doesn't meet those requirements. And you have to absolutely know, if you work for a partner, if you work for whomever, that if you're using a template, for the most part, they're probably not going to meet all of the points in the blueprint. So know the limitations of what you're working with, and make sure that your documentation meets the blueprint, that it hits all those points. Otherwise, you're not going to hit all those scoring opportunities. So that leads us into the next slide. So first commandment, know the blueprint inside and out. It's absolutely critical that you understand what is being asked of you, and otherwise it's impossible to hit your points. The second thing there is be true to the blueprint. So adhere to the elements within. So you have below the customer requirements flowing into the solution architecture, flowing into the engineering specifications. I know a lot of vSphere engineers who are very, very comfortable with that bottom part. So you can stand up vSphere, you can configure HA, you can configure DRS, you can configure clusters, and that's great, but you have to be able to relate requirements like I talked about before. So the business drivers, the things that the business is telling you that they want the design to look like. You have to be able to relate that to a solution architecture, which is a logical design, and then take the components that you outline in that logical design and then add physical hardware into it, as well as software, configuration, things like that. There needs to be a natural progression from one to the other. Otherwise, it becomes very difficult. If you try and go from the bottom up, it becomes much more difficult to try and relate requirements back to decisions that you've already made. Another point there is, so this is something I hit on, it's okay to create fictional items within the design to meet blueprints objectives if they're missing. So that's something that I had to do in a couple of points on my design, and if you can avoid it, that's great, but you need to be able to meet all of the different parts within the blueprint. Otherwise, you're not going to get accepted. So if there's something that is deficient, then it is okay to introduce fictional items. The only thing to take into consideration there is you have to be able to defend them as well as you do, the things that are true to life.
So we have a question.
Sure.
How do customers get access to the templates? And if it's through a partner, what do they ask for?
So the set templates, so the Solution Enablement Toolkit templates are available to partners. As far as I know, they're not available for dissemination to customers. That may be something that is available, but as far as I know, they are not at this point. Any other questions?
That's all we have so far. Thank you.
Cool. No problem. All right, so next slide there is, and we're going to cover both of the major enterprise architecture frameworks, but so the first one here is Zachman, and if you look at what is in this table, and this is a pretty good view of what Zachman is envisioning as an enterprise architecture framework. You start up at the top. On the left-hand side, you have contextual, and then conceptual, logical, physical, and then the detail. And then at the end, you have your functioning enterprise. So that's, everything is built and everything is working. If you look at all of the different columns there and the way that it flows, you can tell a lot of the blueprint items, where they're coming from. So this is something that majorly influences what you're going to be asked.
No one is available to take your call.
Sorry about that. So it's important, you don't have to live and breathe enterprise architecture to get a VCDX. It certainly helps if you understand the frameworks, though. Understanding why it's important to start, conceptual and then go to logical and then physical will go a long way in your thinking about how to put together your documentation set. And it's something that I found that is incredibly important when you approach the process from the point of view of someone. So if you're like me, I started as a customer and then went to a partner, and then I've been at VMware for coming up on a year now. But as I've progressed, I've at that point gone from being a systems engineer to a consultant, and now I'm working on more architecture, as more of a full-time thing. And as you progress, it's important. Oh, no, I've got Siri doing something. Sorry about that. It's important to understand the flow of things. If you're used to approaching problems in one manner or another, and it's easy to get wrapped up in the physical details. Do I want to use IBM or do I want to use HP or do I want to use Cisco? Those are important things to cover, but you look at it from a point of view that a conceptual and a logical design, if they're done very well, they can typically be implemented with any number of different pieces of hardware. So I can design my network such that it will be able to be implemented successfully with Cisco or HP or Juniper. Same goes for my compute. There will be some things that are different between the different systems, but for the most part, a 2U, 2-socket pizza box, is the same across the board. Blade systems, while from a configuration standpoint, will be unique. From an overall architecture point of view, they will tend to be very similar. So I can apply that conceptual level. I can apply that logical model to any given number of hardware. So it's important to not only grasp the physical implementation portion of this, but this is a design certification. So you have to know how to take requirements and turn them into a design, and that doesn't happen from the bottom up. It happens much more easily from the top down.
So we have another question.
So Togaf, yeah, go ahead.
So like the iOS 7-layer model, each level in the framework is independent of the others?
So it doesn't, from my experience, it doesn't necessarily work like that. Absolutely OSI, you have independence there, but with a design, with an enterprise vSphere design, you end up being dependent on the level above you. So if I'm looking at my physical design, I'm constrained by what I've put in place in the logical design. And the same thing goes for the logical design. The logical design needs to meet the things that are laid out in the conceptual model. So the decisions that you make going from the conceptual level to logical to physical will be dependent on the design at that higher level. So like I said, if I'm creating a systems architecture, it's going to be, what I put in place is going to be dependent completely on what my requirements and constraints are. And those requirements and constraints are what make up the conceptual model. Same goes for, the hardware that I put in is going to be completely dependent on the solutions architecture that I define. So they are at the very least loosely coupled, but they're for the most part very tightly coupled, if that makes sense.
Does.
Sure. So Togaf is the other major enterprise architecture framework. This one you can actually go and get certified on. Zachman, I don't believe you can. They're pretty similar in their approaches. I haven't dealt with Togaf really at any level, so this was more just a slide for completeness sake. But from a framework perspective, it is very similar to Zachman. It's vision, take that into architecture, and then information systems, and so on and so forth. So it does lend itself to this process. If you're very familiar with either Togaf or Zachman, you're going to have a leg up on a lot of the other people who are going into this process as vSphere engineer or consultant or architect without that sort of experience. So now we're getting into design components. So this is our conceptual model. The things that go into it are going to be, like I mentioned before, requirements and constraints. So when I talk about requirements, and this is kind of VCAP DCD level stuff, but it's still important to cover here. So requirements are how the environment should look. So for example, so virtual machines shall have 99% uptime. That's saying that the virtual machines within my environment, or let me rephrase that, the environment should be designed that lends itself to supporting virtual machines running 99.9% of the time. You need to know not only what your uptime requirement is, but you also need to know what at that point has to be implemented to keep to that requirement. Another one here is around recovery. So recovery time objective is 1 hour. That means I have, with this requirement, I have an hour to get my workload back up and running, or however I'm defining completion of that recovery. And then I have a recovery point objective of 15 minutes. So that's saying I can stand 15 minutes of data loss when I get my when my recovery is complete. I can stand up to 15 minutes of loss there. So those are important. They're the other design qualities that are there, but it's important to understand the difference between a requirement and constraint here. Absolutely, requirements are what the environment should look like. Constraints, on the other hand, are limitations on the design that are typically injected by the customer. They can also be environmental. There can be any number of sources of constraints. Some common ones are going to be around hardware platforms that you can use. So the thing I have in here is, Cisco Nexus Ethernet switches must be used. That is a constraint. I can't at that point go out and buy HP ProCurve because I have a constraint that says you have to use Cisco Nexus. And that's the difference between a requirement and a constraint. So the requirement is what it should do. Constraints are limitations on what it can do. Or not necessarily what it can do, but constraints on the decisions that you can make. Another common one is going to be around budget. Everybody has a budget to a degree. I know I've heard of folks doing designs, and sometimes running into issues because we have an unlimited budget. We're a big financial firm, and this is a super critical thing, so we're going to throw as much money at it as we can. And to a degree, some of your constraints will actually make your design more interesting. So budget is going to be one that definitely makes it more interesting. Some of your hardware constraints are going to limit you in what you can do, and it's going to make it maybe a little bit more challenging if you're extremely constrained to hit all the high points. As long as you can thoroughly explain what you're doing within those constraints, I think you're good. That's still me being on the side of having submitted a design and being accepted but not being all the way through the process. So that's something that I'm not 100% on. But from my perspective, it's one of those things that you have to work around, and you have to be able to show expertise in working around those constraints. Especially things like budget. So like I said before, budget is one of those things that can make a design much more interesting to look at. So being able to say, I have this $500,000 or whatever the budget number is. I have this pot of money, and I have to take that and come up with an architecture that meets all of the requirements that have been laid out. So at some point you have to make trade-offs, and where you make those trade-offs can make a design very good, or maybe not as good. So that's something that I feel like is one of those things that can really turn a design into something that's really interesting. And down below we have listed all of our design qualities. So RAMPS is the acronym that was given to me a few days ago. It's a kind of an interesting way to remember it, but it's recoverability, availability, manageability, performance, and security. And those 5 design qualities are what all of your different design components will end up mapping to. So my virtual machine shall have 99% uptime. That's an availability requirement. My RTO and RPO, those are recoverability requirements. My budget, that'll hit any number of different design qualities. My hardware constraints, those will hit, availability, manageability, performance. But in the end, they all map to those design qualities, and that's an important thing to remember when you're going through your documentation, when you're going through and creating your design, to keep those in mind throughout the process. So now we're moving on to assumptions and risk. And I need to move this so I can see my whole screen. All right, so assumptions, anything that hasn't been or can't be verified. So something that maybe isn't verified 100% of the time. So our infrastructure services are in good working order. So you assume that Active Directory is going to work the way that it's supposed to. You assume that DNS is going to work the way that it's supposed to. Something that maybe can't be verified, something like growth estimates. So maybe I have great capacity planning, but we have to assume to some degree that the growth of the environment is going to match those figures. We don't have a crystal ball. We can't look into the future, so we don't know 100% that growth rate is going to be sustained. So that's why it's an assumption. Now on to risks. So risks and mitigation thereof are absolutely critical. Being able to show that you can not only identify risk, but either mitigate that risk or as kind of a last step there, get it approved by the business if it's something that can't be mitigated, or if the risk is a couple of requirements that conflict or something along those lines. You may have to just accept them and move on, but it's absolutely, I can't stress this enough. It's something that I struggled with when I first started with the process, was being able to identify things that would qualify as risks. But it's something that as you go through the process that you invariably get better at, because you see not only within your own design, but you'll collaborate with other people and you'll see things that'll potentially be risks, and they're once you get into it a little bit more, it's a little bit easier to point them out. So a couple of examples here. So loss of vSphere management functionality poses a risk to the recoverability of the environment. So that's a risk if I have a VADP-based backup solution, that if I lose vSphere management, that I may not be able to recover a machine on that host. Or if I'm going directly to the host, then I no longer have an avenue into the environment to perform recovery. Another one here is if the vCenter server database gets very large, it poses center server. So this is something, if you've been a vSphere administrator, that you know very well, but it's something that you have to be able to account for in your design. So I have to make accommodations to either a manageable level. Otherwise, it does pose a risk to the performance of vCenter server, and then with vCenter server being that management point for everything within the environment, that can be a big deal if it's offline. may not be, if it's offline for 15 or 20 minutes, it's not a huge deal. But if it's off for days and you're doing backups through it, then more data, and that's where all your inventory is coming from, then that can be problematic. That's definitely a key thing too. And I don't want to stress this too little. Absolutely, assumptions and risks are a very big part of or validation of the assumption or mitigation of the risk is absolutely a huge deal. And just like our constraints and requirements, these should map back to our 5 design. Keep in mind when you're going through and identifying risks and assumptions, you need to know not only that a risk exists, but what part of the design that it affects or that it impacts. All right, so our next thing is a conceptual design. So a conceptual design in and of itself isn't something that's called out by the blueprint. So you have a conceptual model that is called out by the blueprint that consists of our requirements and constraints. But creating a high-level design or a very, very high-level design isn't something that's necessarily called out by the blueprint. I think I may be the only one that I've seen that doesn't have something good for conceptual design, but it was accepted, so I guess that's validation there. It's as long as you have your conceptual model and that maps to your logical design, then I think you have your bases covered from that perspective. But that goes back to my disclaimer. I haven't been all the way through this process yet, so if I would definitely take that with a grain of salt. So our next step is our logical design. So this is the solution architecture. This is lower level than conceptual model, higher than the physical, should be informed by the conceptual model. So what that means is the solution architecture should be the decisions that you make to come up with the solution architecture should be 100% based on your conceptual model, based on your requirements, your constraints, based on assumptions that you've made or things that you can't verify, and then mitigation of risk. So those absolutely inform the solution architecture. An important point here, you shouldn't have named infrastructure components at this point. So if I say that if I'm creating my logical design, somewhere in there I say, well, I'm going to use Cisco Nexus switches. At that point, it's not a logical design anymore. You're calling out things that you're putting into the infrastructure, your individual components. At that point, it is a physical design. So it's something to keep in mind. Bottom point here, so since this is a VMware certification, you'll necessarily call out VMware products or components. At this point, this is okay. So it's not really the same as calling out my server manufacturer, my switch manufacturer, or whatever. At this point, calling out your vSphere components is acceptable and appropriate. So that leads us into design decisions. So design decisions are what you use to create your solution architecture. So you'll have many different points at which you have to make a decision to go one way or another. At each of these points, your decision should be well defined and called out within the document. So that's something that the blueprint hits on pretty well. And absolutely, and there's a reason it's underlined, include justification and impact for every single decision that you make. So if I have a decision that I'm making within the solution architecture, if it's important enough to be singled out as a design decision, I need to include justification and impact for that design decision. Traceability. So this is something that I haven't seen a ton of, but it's something that I put quite a bit of effort into. Showing how your design decisions relate back to the conceptual model, or mitigate assumptions or risk. And I feel like this is a very important point. So something you can see down here with my example design decision. So network segmentation within a management zone will be achieved logically via VLANs, and then I have the DD048 because it's design decision number 48, rather than relying on blah, 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 blah. Going down, we have it, so we have R004, which is a requirement that was defined, C014, which is our budget constraint, and then a security constraint at the end. So we're showing the decision that we made, we're showing why we made it, and what it's doing within the environment. And those are absolutely important things to cover on your design decisions.
So we have a kind of a two-parter. How much is it safe to assume, and where are the limits of the systems?
So on your assumptions, you only want to make assumptions when you absolutely have to. So, and this is just a general architecture thing. It's if you can verify something, you should verify it. Absolutely, you need to identify where there are things that you can't verify. But if there's a question whether I leave something as an assumption or I go in and do the legwork to figure something out, I'm absolutely going to do that legwork. So only assume when you have to. And what was the last part there?
Where are the limits of the system?
I don't know that I understand the question.
Graham, can you elaborate more on that question? Let's see, what are the limits of what's included in the defense?
So the limits of what the panelists are going to ask you about? Is that the...
Or should we assume DHCP is included or not?
So if
or
you
AD.
rely on DHCP, so if you rely on AD or DHCP, they need to be at some point verified from a functionality point of view. If it's something that you're maybe touching, but it's not a key part of your design, then I think those are things that are okay to leave as assumptions. But if it's something that's integral to your design, so if I'm doing auto deploy, and at that point I absolutely need to know that the infrastructure required for auto deploy is going to work, then I can't leave that as an assumption. Otherwise, from my perspective, that's a pretty gaping hole. So if something like DNS, so DNS is pretty integral to most designs, you need to make sure that it works. If I'm doing a view design and I'm doing link clones, I need to know absolutely that KMS works. Otherwise, I'm not going to be able to deploy Windows 7 desktops based on or using that KMS. So those are the kind of things that you have those dependencies, and you can say, yeah, I'll just assume that's going to work. But like I said, if it's something that's going to have a very big detrimental effect on the implemented design, on the implemented environment, then you need to verify those things.
I will say from experience, don't assume DNS is in place or working properly. That's just from experience.
Yeah, that's one of those things you need to make sure that you got that rule of 4 resolution, short, long, reverse, and forward.
We also have Joe says, I've heard that anything is fair game, including facilities, and he's got power/cooling.
Yeah, so if it's in your design, you can be questioned on it. And presumably your equipment's going to go in a facility, so you need to be able to answer questions about facilities. Absolutely.
Thanks.
Yep, no problem. All right, so onto our physical design. So this is the lowest level, and I really hate putting my diagrams up here just because I think they're horrible, but this is the lowest level of our design. So this is the hardware that I'm putting in place, how I'm connecting things, how it's going to be laid out within the environment. You know, I have names in here. I have how things are physically laid out. So this is, it doesn't get more low level than this. So next point there, this absolutely should be informed by the logical design. So the design decisions that I make in coming up with my logical design should inform the things that I put in place. You know, it kind of logically flows, but it's something that, you know, if you're not used to the process, there might be a little bit of a disconnect there. Placement of the physical components, you know, switches, servers, etc. within the design. So you can see here I have, so I'm doing an IBM Blade deployment. So we have chassis that connect to switches in the chassis, and those go up to top of rack stuff from there. So you can kind of see the layout from my horribly drawn design diagram here. But this is the point that I want to make there is that this is the point where you're actually starting to call out components that you're implementing, so physical components. So if I'm doing a storage design, this is a point where I'm going to say, okay, I'm using an EMC VNX. Whereas at the logical design, you know, I'll say I'll use a fiber channel array or something along those lines. So now we're into our additional documentation. So not to be overshadowed by the architecture design, but you know, obviously the architecture design is the biggest part of your submission. The implementation plan here is a guide that shows the person reading it how you get from point A to point B, how you get from your project kickoff to handoff at the end of the engagement. So this is a project plan, this is a timeline, and all of your steps involved. So this is something that you can make a little bit high level, or it's something that you can go very deep into. I think mine ended up being something like 10 pages total, with a page dedicated to the project plan, but you know, breaking out all of the individual steps that have to happen to get from point A to point B is, and being able to understand what it takes to get from point A to point B is a big thing here. You know, you don't have to be a project manager. You don't have to, you know all of the terminology or whatever for the planning, but you have to be able to show that you can shepherd a project from beginning to end, and that's where this comes into play. Now the installation guide. So this is providing guidance on installation and implementation of the design. So this should include detailed steps for focus of the design. So I can, at this point, you know, I don't necessarily need to show all the steps for instance, provisioning a switch or configuring LUNs on an array. It's certainly helpful if you can include that kind of detail, but at this point I don't think that detail is actually required. So long as I know so if I'm a vSphere administrator and I have different groups that do different things, so I have a storage team, a network team, so on and so forth, I need to know what they're doing, but I don't necessarily need to know at a very granular level how to do it. So as long as you can cover those topics at a high level, I think you're fine here. But certainly you need to know, from soup to nuts, if you're doing data center virtualization, what you're doing configuration-wise or installation-wise with vSphere. If you're doing desktop, you have to know all that stuff. Sorry about that. It looks like my audio dropped. But if I'm doing desktop, I have to know soup to nuts how to implement Vue, and it has to be on paper. So additional documentation, operational procedures. So this is our standard operating procedures in running an environment. So this is, our routine things like, we perform backups every night, or we do incrementals every night, and we do a full backup every week. Things along those lines. So we run monitoring scripts every day, or we run X script on Monday, and we run Y script on whatever. Those are things that need to be outlined at this point. Also, are non-routine tests. So I need to know how, in the event of an emergency, to proceed. So that's important to outline at this point. On the routine tasks, so you need to include things that happen day to day. So vSphere administrator logs into the vSphere client, observes what's going on, make sure nothing's breaking, stuff like that. But also things that happen periodically. Like I said, backups. So if I have a DR plan and I need to verify it every 6 months, then that needs to be in here. If I have backups that go to tape and then they get shipped off site every month, then that needs to be in here. Now our test and validation plan. So this should, like I said, show how the environment would be verified as functional. So if I'm implementing vSphere, I need to be able to show things like HA failover. I need to be able to show resilience of the environment with the loss of an individual component. So these are things that, as a person who goes in and does a vSphere implementation, may be somewhat tedious, but it's stuff that you have to outline in this document. It's, I need to know that if I pull a chassis switch, that everything keeps functioning. I need to know that if I pull a blade, that VMs fail over from one to another. I also need to verify that the implemented environment meets the guidelines given by the architecture design document. So I need to not only know that the environment works, I need to know that it's been implemented as was outlined within the architecture design. So I need to know that if I say, I'm going to have 4 clusters, I need to verify that I have 4 clusters. It seems trivial, but it needs to be addressed. All right, so last piece of documentation we've got there is the application. Make sure that you leave yourself enough time. And I laugh because, and I have a bullet here, I planned on about 2 hours, but I ended up spending double that because apparently I don't know how PDF forms work or something. The first time I filled it out, I thought I saved it, and it looked like it saved, but I went to open it up the next day, and it was not saved. So you don't necessarily need to plan on messing up on your application, but certainly be able to put some time into it because it's not a trivial thing. You should here be able to reference items within the design, so you have to be able to outline your requirements, constraints, assumptions, risks. You have to be able to talk to it at a high level. And this is when you're filling out the application. These are fields that actually are required within the application. So it's stuff that you have to be able to address. Especially important is other contributors to the design and their role. So we very rarely work as an island. We usually work within a team, and if there's and certainly attribution is important here. But as I've been told, the important thing here is if multiple people are going to possibly submit the same design, you need to know the role of people within the group submitting, so you can identify who did what.
So how would that work? Let's say me and you are both vSphere admins, and we're going after our VCDX, and we submit the same design. We play the same role. How does that?
So at that point, it doesn't necessarily make a difference that you both play the same role or that we're both doing the same thing. So long as we're showing that we work together, and we are at that point both going to be required to defend the entire design. So if it's, you did the San Antonio office and I did the Dallas office, we still both have to be able to defend the entire design. It's more of an attribution, and making sure that if people did work together, that you're being upfront about it, and that everybody has to defend the whole thing.
Gotcha. Thanks.
So now we get into level of effort. So I put a whole lot of time in this. If you follow me on Twitter, you will routinely see me griping about it, but I really haven't done anything else since the beginning of July. So it's middle of September now. I haven't really. I don't know. I sort of remember what my kids look like. My wife waves at me when I come home from an engagement. She says, "Hey, how's it going?" "All right, I'm gonna go upstairs and work." So it's absolutely a commitment that you have to make, and you have to stick with it. So to me, certainly I've learned a lot in the process. It's been an overwhelmingly positive thing to me and my skill set, but it has absolutely been a test of sticking with it, having the tenacity to put in the hours, because it's not something that comes easy. If you expect it to come easily, you either need to be a whole lot smarter than me, or you're not going to finish it, or you're not going to come up with a product that's going to be acceptable. So put in about 290 hours into the architecture design, and when I say 2 complete rewrites, that means starting over from scratch twice, which sucks when you've put a lot of time into something. But I just got to the point where, the first time what I had wasn't great quality. The second time it was more of the format that I had things in. This was me learning that, excuse me, the template that I was using was not necessarily up to the task. So, starting not necessarily from scratch, because I had all my decisions made. I had a lot of my diagrams already done, but it was still, starting with the existing document as kind of a framework, but completely rewriting the entire design. The additional docs took me it took me a good week to finish, including review and edits. The applications, like I said, took me 4 hours, which was just doing it twice because I'm stupid and don't know how to save the PDF form. Then you submit, and then you worry about getting accepted. That was not a great experience, but it's part of the deal. You got to get your design reviewed by everybody. So it's waiting is not one of my areas of expertise. So I worried about it quite a bit. So that was a fun couple of weeks. All right, so that's basically what I got. I got some resources up here. So me, Adri Shiplett on Twitter, my blog, which I never write on anymore because I've been doing this pretty much nonstop for the last 3 months. So the VCDX Bootcamp book is fantastic. I don't know how many times I've read through it, and every time I go through it, I find something new. So it's absolutely worth picking up. vSphere 5.1 clustering deep dive, absolutely essential. Knowing HA, knowing DRS. If you're doing a DCV submission, it's there's no better reference. Storage implementation, vSphere 5 by Mustafa Khalil. You are going to have to defend your storage design and potentially too, Mustafa. So reading his book isn't a bad idea. Networking for vSphere administrators. I threw this up there. It's not necessarily a deep dive like the other books are, but it's something that I find a lot of, especially from the consulting side, it's something that I find a lot of the vSphere admins that I work with don't have a great grasp on. So absolutely brush up on your networking. Absolutely know, why if you're doing software iSCSI that you wouldn't use LACP. That's something that if you ask, a pretty big percentage of vSphere admins wouldn't be able to tell you why. So absolutely know that stuff. And this just comes down to you have to know the fundamentals very, very well. You don't have to be a mile deep in everything, but you have to be well versed enough to speak intelligently on every single topic. Below that, so the vBrownbag VCDX bootcamp with John Rashid was great. I know I'm covering a lot of kind of the stuff that he did in there, but absolutely worth your time to go back and watch those. And then below that I have the VCDX Linkorama that Derek Seaman keeps up. So he posts up all of the experience posts that people put up when they've gone through, and he's got a bunch of book and article links there as well. So absolutely check that out. Q&A. Any questions?
As of right
None?
now, I don't see any questions on Twitter, nor in the go-to. You just did an awesome job, man.
So great at covering all of your questions before you ask them. All right. Well, that's me. Like I said, if you want to reach out, feel free. I'm not really doing much else besides this right now, so if you got a question on it, feel free to reach out.
So you're
I'm usually available.
Let's see. So you're about to defend in 2 weeks, correct?
Yep. I'm defending on the 7th in the afternoon in Palo Alto. So.
Well, good luck.
Wish me luck.
Hope to see that tweet that says I'm VCDX number, and then your number.
I'm getting close to 10,000. I'm toying with the idea of getting to 9,999 and having that 10,000th tweet hopefully just be a number. That's what I'm hoping for.
Well, good luck, my friend. I know you'll rock it.
I appreciate it.
Let's see. We do have a question. So what was the time between the submission to design acceptance and then from acceptance to defense?
So the time period from submission to acceptance was the deadline was the 8th of August, and the acceptances went out, I want to say, about a month later. And then it was another month to defense. So that was about 2 weeks ago, and we've got 2 weeks to go. So yeah, that makes sense. About a month between.
Any more questions, comments? Joe says, great presentation, by the way.
I appreciate it. My first one of these, so keep giving me good feedback and I'll do it again.
Graham says, thanks for taking the time out tonight.
Sure thing.
Yeah, my first one as well, hosting, so solo. So
Wait, you didn't mute me once or anything.
Yeah. I promised no muting, so I think I stuck to that.
I think so. I think we rocked this one.
Yeah, you're right. I'm no Josh Atwell. It's my first one though. Give it time.
Yeah, it'll
Uh,
happen eventually.
let's see. Let's see. What was your weakest area coming in, and how did you address it?
Everything, is that an acceptable answer? I don't know. I would say my network design is pretty strong. My storage is pretty good. I had a lot of trouble. So this is going back to using a design that I did a few years back. So I'm coming into this process with no hard data and coming up with um, so CPU sizing and memory sizing. If you have hard numbers that you get from Cat Planner or something like that, it's just math at that point. If you're making the numbers up, getting to a point where things seem right, where they seem believable, to me it's something that I spend a lot of time on in the beginning. So that's exactly the reason why I said if you're going to go into this, if you have that data, even if you don't think you're going to do it for a while, save it. Make sure that you have that sizing data. I think that was probably the most difficult. This is something that I do on a pretty regular basis in my day job. So doing the design wasn't. I mean, it was learning my strengths, learning my weaknesses, trying to address them throughout the design, and it was certainly from a skill set point of view. Being an architect, it's something that I've really taken a lot away from it. Even if I don't pass at this point, I'm a better solutions architect because of it. My skill set has expanded because of it. So it's absolutely worth the process. It's absolutely worth the time. But going back to the question, I would say it probably the sizing portion, just because making all that stuff jive was challenging.
Let's see. I presume it's okay to deviate from the recommended practice as long as you can defend the decision.
So defending something by saying that it's a best practice is not going to be acceptable. You have to know why a best practice is a best practice, and you have to know how it applies to your design. You have to know how it meets your requirements and constraints. If it doesn't, then how good of a practice is it? So absolutely, you need to know where to deviate from quote-unquote best practices, or your personal best practices, as they may be. You got to know where things fit. You have to know absolutely how those best practices play in your design and where they don't. So yeah, absolutely.
Let's see. And do designs need to include UC, or can they avoid those kinds of miles, deep areas, if you don't have any expertise or experience?
So I would absolutely recommend against submitting a Vue supporting design if you don't know Vue, because you're going to get asked on it, because it's part of the design. If you're submitting a VCDX data center virtualization design, it doesn't need to include any extra components. So it doesn't have to include SRM. It doesn't have to include vCloud. It doesn't have to include VCAC. It doesn't have to include Vue. So as long as you're addressing the major focal point of the design that you're submitting, so if I'm submitting for data center virtualization, the focus is vSphere. If I'm submitting for desktop, then yeah, at that point I have to have Vue in there, otherwise it's not a desktop design. But yeah, I would I would shy away from submitting a design with stuff in it that you don't know, because you're going to get asked about everything, or potentially asked about everything, at least.
Any more questions? Well, looks like that's it. Definitely appreciate your time, Jason.
Yeah, no problem.
And good luck.
Thanks, I appreciate that. It's been a slog. I don't want it to be for nothing.
All right, with that said, I'm going to go ahead and stop the recording.